We at tousimis are pleased to introduce the Advanced Touchscreen 931 series to our family of critical point dryers. The 931 uses new advanced programming specifically designed for multi-application processing. From bio to MEMS to powders to gels, the 931 stands ready to take on your most difficult samples. The 931 comes with all the quality features you would expect from a tousimis dryer, but to expand the range of samples to be processed automatically, the 931 comes with a newly developed patent-pending Stasis Processing. What is Stasis Processing, and why is it needed to successfully process thicker samples? After dehydration, when you have a thicker sample placed in the chamber, its interior is saturated with intermediary fluid, such as ethanol or IPA. In this graphic, the red lines represent the intermediary fluid. During the purge mode, liquid carbon dioxide is pumped into the cooled chamber while the intermediary fluid and liquid carbon dioxide exit through the vent port. The problem with the thicker samples is that the intermediary fluid can be exchanged out of the chamber fluid, but can still remain inside of the sample. When the chamber rises above the critical temperature and pressure, the sample structure will collapse due to the internal intermediary fluid still present inside of it, and an incomplete drying will occur. The stasis mode is essentially an optional extra phase that has been added to the run that allows the sample to sit in the chamber for a selected amount of time and to cycle through the stasis phase for as many cycles as the operator deems necessary. So the time in stasis and the amount of times going into stasis are fully programmable. If the operator has a sample that will need the stasis mode, it can be selected from the main menu. The user is first allowed to customize any standard run parameters, or just choose to enter the stasis programming. At this point, the time in stasis can be selected, followed by the amount of times to cycle through the stasis mode. Now, the fully automatic process can be initiated. The system will cool, fill, and enter purge. Then enter the stasis phase. During stasis, the system will begin to count down. Depending on the duration of stasis time, the chamber can leave its cool state and rise up to room temperature. The chamber contents will remain in a fluid state since the temperature is not over the critical point, but the physical properties of the fluids will change, becoming more favorable for sample processing. During the stasis phase, the chamber temperature will slowly rise up to room temperature, from 0 degrees to around 22 degrees Celsius. With this change, the fluid viscosity, or the amount of fluid resistance, will go down. At the same time, the density of the fluid will go down also. These changes in fluid dynamics will allow for more fluid penetration in and out of the sample. To visualize an example of this principle of fluid dynamics at work, imagine a sponge sitting on both molasses and water. With molasses, you have a higher viscosity and density fluid, and as a result, lower penetration into the sponge. With water, you have both lower fluid viscosity and density, and therefore more penetration into the sponge. Upon completion of the process, the samples can be removed from the chamber. What was a saturated wet sample has now successfully dried with its structural integrity intact. The sample and its structure has been freed from any of the stiction forces caused by residual internal fluid. In conclusion, the tousimis 931 series, with its standard features and access to the patent-pending stasis processing, gives the user the advantage when taking on thicker, more difficult samples.